Hello, and welcome to MG Chemicals Tech Talk, Episode 12, Electroplating. In today's demonstration, we will be using a copper sulfate solution. We also need a power source which carries the metal ion from the anode to the cathode. The power source we're using is a 50 VDC source, but you can electroplate with a battery if you like. Also needed are lead wires for the positive and negative terminals of the power source, and a magnetic stir bar to keep the copper sulfate solution in constant agitation. The cathode, or substrate that's being plated, needs to be made electrically conductive in order for there to be electrical potential between the anode and the cathode. We will coat the parts with our 841AR nickel conductive coating. Use a non-conductive container to carry out the plating process. Ensure that its size allows parts to sit fully immersed in the plating solution. Now let's start setting up. We have our two leads connecting the power source with the anode and cathode that make up the cell. In this demonstration, we'll be using a copper strip as the anode, but you can use other metals like brass or tin. For the cathode, we'll be plating the barrel of this pen. Now let's connect the terminals to the anode and cathode using alligator clips to secure each part. Now connect the other ends of the leads to the power source, which should be color-coded, showing where the red and black leads should be connected. Here are two small cam parts we made using a 3D printer that we're also going to be electroplating along with the pen barrel. Now coat the parts with an electrically conductive paint like our 841AR. Paint is an ideal solution for complex parts like cams, which have many edges and fine details. The paint conforms well to these shapes, ensuring the whole part is conductive and should plate evenly. The paint can be applied either by spraying or using a brush. Now it's time to plate. Pour the copper sulfate solution into the container and place onto a magnetic stir plate. Place the stir bar in the solution and turn on the plate to ensure constant agitation. With the anode placed in the bath, add the cathode, ensuring it is fully submersed in the solution. Try and place the anode and cathode relatively close to each other, which will speed up the process. Turn on the power source, which will begin to oxidize the anode strip, releasing metal ions into the bath. The electric current shuttles the ions towards the cathode surface, where they reduce to copper metal. Here, we use 20 volts and 1.5 amps to plate the parts, but you may require more or less current depending on the combination of anode and cathode.